Hey everybody, welcome back. So today we're going to be talking about the unit circle. Now hopefully you remember this back from geometry or trigonometry. Today we're going to concentrate on setting this up and in particular figuring out what happens here in the first quadrant. Um, and before we get to that, just a little bit of setup. So what is the unit circle? So I mean by itself, the name unit circle, all this means is it's a circle of radius 1. Wow, there we go. Centered at the origin. And if you're curious, the equation for the unit circle is x squared plus y squared equals 1. Okay. But in this class, the unit circle is going to mean a lot more. So as pictured below, notice it is a circle. It does have radius 1, or at least we're going to declare it to have radius 1. But it's also going to capture a lot more information. So notice we have a bunch of angles here that we have. We have coordinates on the unit circle. We have this positive and negative business. So yeah, the unit circle is a circle, but it's also capturing a lot of information that's going to be important for when we define sine and cosine, which we'll see in the next video. So again, today what we're going to concentrate on is we're gonna fill out all the angles, and we're gonna fill out all the coordinates in the first quadrant and some other special coordinates as well. And then in class, you guys should fill out the rest of these. So let's go ahead and start with the angles. Okay, so the unit circle right here on the x-axis, okay, it starts at 0 degrees. Okay, and what is 0 degrees in radians? That's just 0. Okay. Now each big jump here on the unit circle is 30 degrees, okay? Or, hopefully you guys remember your conversions, pi over 6 in radians. Okay, now each small jump is 15 degrees. So this would be 45 degrees, and in radians, that's pi over 4. Okay. And again, we have another small jump here next, so we have 60 degrees. And 60 degrees is pi over 3 radians. Okay, and then again, we have a big jump. That's 9, so we'll be at 90 degrees now, and 90 degrees is pi over 2. Okay, so this is how you start filling the angles. Start at 0, big jumps correspond to 30 degrees, smaller jumps correspond to 15, and you keep doing that all the way around the unit circle. Okay, everyone, so this is what you should get after going around the entire unit circle and filling in all the angles. I did it for us so you didn't have to watch me do every single one of these here. Now, again, the unit circle has the angles here that you see, and this is what we would call one standard rotation around the unit circle, but it also incorporates some more information. Okay, so first of all, positive and negative, and notice we have coordinates here on the unit circle. Okay. So today what we're going to talk about is this first quadrant here, and actually some of the other special coordinates as well. Okay, so let's start with the easier coordinates, the ones that are on the x and y axis. So notice this point right here. Again, remember this is the unit circle. It has radius 1. So this point automatically has to be 1, okay, comma 0. Okay, because remember this right here, think about this line as the x-axis, and think about this line as the y-axis. Let's not. Actually, I will write with highlighter. Why not? Okay, so that point's 1, 0. Up here at 90 degrees, that point is 0, comma 1. Over here, on the negative x-axis, this is minus 1, 0. And down here at the bottom, this is 0, minus 1. Okay, so these 4 points, the points that are on the x and y axis, these are the easiest points on the unit circle. The other ones you're going to see we have to figure out by using geometry. Okay, now before we figure out these other 3 coordinates here, I want to comment on what do we mean by positive and negative. So once we determine, or once we define our trig functions, positive and negative is going to correspond to us, or it's going to mean which trig functions are positive and which trig functions are negative. since we don't know what the trig functions are yet technically, right now what I'm going to write down for positive and negative are just x and y. Okay, so for instance, in the first quadrant, both x and y are positive. Okay, remember this is quadrant 1. In quadrant 2 over here, okay, notice x is negative, but y is still positive. In quadrant 3, okay, both are negative, x and y. And then in quadrant 4, x is positive and y is negative. Okay, so right now that's what positive and negative is going to mean for us. It's going to capture what coordinates are positive and negative in each quadrant. Now, when you guys learn about the trig functions, what I recommend you do is go back and replace x with whatever trig function x corresponds to and y with whatever trig function it corresponds to, because that'll be more helpful in the future. But for right now, positive and negative, that's just meaning which coordinate is positive and which coordinate is negative. Now, with that out of the way, let's go ahead and figure out these 3 coordinates here. So let's start with 45 degrees, okay, this middle coordinate. Okay, now the way we're going to figure out what this coordinate is, we're actually going to, and you're going to see this a lot, or at least another time today, we're going to take this point and we're going to drop it straight down to the x-axis. Okay, now when we do that, notice it makes a right triangle, okay, whose base angle here is 45 degrees. Okay, so what I'm going to do right now is I'm going to take that triangle, let's pick it up, and we're going to move it right here. Okay, and now remember, we're trying to find this coordinate, right? Which means we want to figure out what this side is, because this is representing the y coordinate, and this side, which is representing the x coordinate. Okay, now keep in mind, we're dealing with the unit circle, right? And this side right here, the hypotenuse, that's the radius of the unit circle there. Again, if we go back up, okay, notice our hypotenuse right here. Okay, that represents the radius of the unit circle. So we automatically know that. We get that for free. That's just 1. Okay. But now we have to figure out what x and y are, because again, we want that coordinate. We want that x comma y. Okay. Now the way we do this is, again, we're going to use geometry here. Okay, so if this triangle has 45 degrees here, we know that this is 90 right here. Automatically, we know that this angle right here has to be 45. Okay, and that's great for us, because notice we have a 45-45 triangle, and what does that mean? Well, if you guys remember your geometry, since these are the same angle, these 2 sides, x and y here, have to be the same. So we know right off the bat, and let's just, for simplicity, we're going to call y x. So these 2 sides have to be the same thing. Again, because it's a 45-45 triangle, these 2 sides have to match up. Now to solve for x, we use our favorite theorem, Pythagorean theorem. So we know that 1 squared is equal to x squared plus x squared. Okay, remember c squared equals a squared plus b squared, the Pythagorean theorem. We're using that on this triangle right here. Okay. So 1 squared is 1 equals, notice we have x squared plus x squared, which is 2x squared. Okay. So now we just have to solve for x, divide both sides by 2. And we get x squared is equal to 1/2. Take the square root of both sides. And we're going to take the positive square root in this case. So we get x is equal to 1 over the square root of 2. Now this is one of the few times I actually do this. We're going to go ahead and rationalize the denominator, because we actually get something that should look familiar from geometry or trig. Okay, so again, we're rationalizing the denominator. Square root of 2 times square root of 2 is just 2, and 1 times the square root of 2 is square root 2. Okay, so we get x is equal to square root 2 over square root 2. So going back to our triangle here, we get that the coordinate here has to be square root 2 over square root 2. I'm sorry, square root 2 comma square root 2 over 2. It's a mouthful, everyone. All right, so going back to my unit circle, and let me go ahead and erase this triangle for a second. Let's put that into our coordinates here. So this is square root 2 over 2, comma square root 2 over 2. And that was coming from the 45-45 triangle. Now for our other two coordinates, we can get two of them by looking at the same triangle, and we'll see that in a second. Okay, so let's focus on the 60-degree one. So again, we do the same trick. If we want to find this coordinate, we're going to see where we actually get that coordinate too. But we're going to drop that coordinate straight down to the x-axis. Now pretend like that's a perfectly straight line there. And again, that's going to generate a right triangle whose angle here is 60 degrees. Okay, so again, let's pick up that triangle. I'm going to bring it down. Okay, so that we have this. Now notice I kind of jumped ahead a little bit. If this is 60 degrees here, that means that this has to be 30. And again, that's why we get those two coordinates for free, because we'll get the 30 degrees as well. Okay. And same thing as before, remember we want this coordinate. We want our x and our y. Okay. And because this triangle is coming from the unit circle, this is still 1 here. Okay. Now in this case, we're going to be a little bit tricky. So I'm going to erase y for a second. I'm going to put y right here. What we're going to do is we're going to glue together the same triangle, but reflected. Like this. So let's call this 60, and then now this is 30 degrees. And so again, we're just gluing together the same triangle. Now the reason why we're doing that, notice what kind of triangle does this become? Okay, we have 60, 60, 60. That's an equilateral triangle. And what's nice about equilateral triangles is that means that all sides have to be the same. Okay. In particular, that means that this, here, let me complete the picture here. That means that x plus x has to be equal to, well, the other sides, which is 1 in this case. So we know that x plus x, okay, since this side right here, let me go and erase because it's getting kind of crowded. This whole side right here has to be equal to the other sides. Okay, but what is this side though? The side is x plus x in this case. So we get 2x is equal to 1, x is equal to 1/2. Okay, so our x coordinate is 1/2. So I'm going to replace x here with 1/2. Okay. Now to find out y, or to figure out what y is, we're going to use our favorite theorem. We're going to use the Pythagorean theorem, and we're going to look at this triangle here. Okay. So we know that 1 squared is equal to 1/2 squared plus y squared. Okay, 1 squared is 1, 1/2 squared is 1/4. Okay, solve for y now. Subtract 1/4 from both sides. Okay, now what is 1 minus 1/4? Well, if you have 1 is 4/4, so 4/4 minus 1/4, that'll just give us 3/4. And take the square root of both sides, and we're going to just consider the positive square root. We get positive, y equals positive square root 3 over square root 4, which is square root 3 over 2. So our y coordinate is square root 3 over 2 in this case. Okay, so remember that. X was 1/2, y was square root 3 over 2. So going back to our unit circle, x was 1/2, y was square root 3 over 2. And now again, like I said before, for this other coordinate, we actually get this for free, because if we were to drop this down, we would get 30 here and 60 here, which is the opposite of the triangle that we just looked at. So all we have to do to get these coordinates is flip the ones that we just got. So the x coordinate here should be square root 3 over 2, and the y coordinate is 1/2. Okay. And now we've completed, get rid of all this other stuff, we've completed the first quadrant of the unit circle. And once you have that, you actually have the whole thing, which you guys are going to dive into during class today.